Hello, everyone, and welcome to our renewable energy webinar today covering the integration and remote sensing into ArcGIS. My name is Alessandra Milliken, and my colleague Scott Newlis and I will be your hosts today facilitating today's webinar. So on behalf of all of us, welcome to our webinar today, and we're really excited to have you. Before we get started, kind of the usual, we wanted to take a few minutes to note the webinar control panel on your screen. So we really encourage you to post questions as they occur to you. We address those at the end. Those are going to be in the GoToWebinar questions dialog box. At the end of our presentation, we're going to answer as many general questions that can be answered concisely as time permits. Questions that need your account team or have longer answers, or maybe more technical questions. We will be taking note of those and reach out to you after the presentation. And anything we can't cover, we will be submitting in a frequently asked questions document, which we'll distribute to all attendees after the fact. You can switch between telephone and computer speaker audio and adjust your view to full or partial screen. As always, today's webinar is being recorded. So with that, thank you so much for being here, and we'll go ahead and get started. So many of our webinars focus on the renewable energy life cycle and the GIS workflows associated. You'll find this webinar to be in that same vein. To start, we're going to showcase imagery in the early stage development and prospecting, and how Esri already gives you access to the tools and data to assist in site suitability assessments. We're about to see a really vast collection of imagery use cases for renewables throughout the renewable energy life cycle. And really the technology that Esri offers to help renewables stay competitive is ArcGIS. From project development and performing due diligence before an area is selected, to groundbreaking at new project site locations, or even ongoing maintenance and operations, imagery is a really key part of every phase. And we're very excited to show you how to utilize this powerful imagery in ArcGIS specific to your renewable energy workflows. First, as always, one of the first questions Scott and I always get asked is what kind of imagery content can be fed into ArcGIS? So ArcGIS integrates all types of data. The level of support for imagery providers, formats, and processing levels is astounding. So from JPEGs, TIFFs, satellite, aerial, drone imagery, LiDAR, radar, multidimensional, multispectral, all of this content can be brought in from local files, cloud storage, or even web services. So basically, if your data has an imagery component, ArcGIS is ready to help you consume and analyze this information. Now that we know that ArcGIS supports all forms of content from different sensors and formats that your organization may own, this content can be managed and made accessible through the image management components. So this primarily uses mosaic data sets to manage large collections that can then be directly accessed or made accessible as image services, with processing applied as the data is accessed or persisted as new data sets. The map production capabilities of ArcGIS are the tools that allow you to generate derived products from imagery such as orthophotos, DTMs, and 3D mesh. The visualization and exploitation capabilities enable human interpretation of imagery and include the many interfaces to interact with those imagery and resulting information products. And we get a lot of questions about this in renewables. The analysis and AI capabilities of the ArcGIS platform provides the tools to extract information from imagery, including a wide range of machine learning and deep learning tools like change detection, or tools used for greenfield analysis for renewable energy project locations. And Esri's work in imagery has been developing a comprehensive system in imagery and remote sensing, which is especially useful in renewable energy. For image management and analysis, Esri has extended the tools to manage and share massive collections of imagery from nearly any source to better support image cubes that provide fast access and analysis of multidimensional data. For map production, Esri continues to extend these tools to generate imagery-derived products such as orthophotos and terrain models and stereo editing. And in image analysis and classification, Esri has extended the deep learning capabilities to provide complete and highly scalable workflows to train and perform inferencing on all types of imagery, as well as increasing the tools working with large multidimensional data sets used in many scientific applications. So now that we have a better understanding of Esri's imagery and remote sensing capabilities, let's talk about the content already available to you. ArcGIS includes access to the living atlas of the world, with maps and applications from Esri and thousands of contributors such as NOAA, USGS, or even the European Environmental Agency. So the living atlas of the world already has over 7,000 ready-to-use maps and data sets, as well as millions of data sets that our users have shared, and billions of maps are made every week using this content. And this content continues to improve. So while it's important to note that Esri is not a data provider per se, access to this living atlas allows us to seamlessly integrate this already available information without having to download and manage all of this data, so we can use all of it together for analysis. And Esri even has agreements in place with many of our partners that allows us to provide image data. So if you need, specific content for a project location site, additional image resources, we would be more than happy to connect you with Esri's large network of partners that provide these services. So while having access to these layers is incredibly valuable, having the ability to bring these layers into ArcGIS to visualize this information with other layers we might have and dispense this authoritative information to the rest of the organization, especially when it comes to the early stage development and prospecting of renewable energy project sites, is so valuable. Having access to that authoritative data allows us to perform weighted analysis on criteria that's important to our individual project site and aid in the speed of process of that site suitability analysis. So now Scott will show us an example of a few configurable applications that integrate imagery and raster data sources to identify the most suitable locations for our potential renewable energy project development sites of interest. Scott, over to you.
All right, thanks, Alessandra. Let's share my screen here. All right, there we go. And welcome, everyone. Thanks for joining us today from wherever you are around the world. I know we've got a lot of people on the call, so we really appreciate taking your time out of your day. And just like Alessandra mentioned, there's really a lot of applications for imagery across the renewable project development lifecycle. And all of the imagery and remote sensing capabilities that Alessandra just talked about can be a little overwhelming, but it's actually quite easy to get started. So what we're looking at here on our screen is a proposed site for a new solar project. And looking at this AOI here on the map, we've got an imagery-based map loaded in. It might be a little random figuring out why, of all places, we selected this as a potential site. And in order to really understand all of the processing and criteria and factors that went into identifying the site, we really need to take a few steps back and kind of rewind our processing to the very beginning of this workflow. So many of you that are involved with project development do a lot of prospecting to find new sites, and this is really critical to project success. And this is often done not at a local scale like we were just looking at, but at a regional or national scale, and really trying to identify the best sites or group of sites depending on all of the different criteria that you're interested in looking at as an organization. Now, one of the biggest challenges for these prospecting workflows is finding authoritative and relevant data that's in the right area that you need or that is up to date. And there's actually a lot of data already included in ArcGIS that many of you can use in your workflows today. So looking at our living atlas that I can access here through our web viewer in ArcGIS Online, I can actually search for a ton of relevant imagery layers. So I can search for, if we're looking at a solar project here, let's say the Global Solar Atlas. I know that's a layer here in the living atlas. If I click on that, I can see, one, it's an imagery layer, and then two, a description of what it is. So this is a collection of layers for the assessment of solar projects. Now, when we think of imagery, a lot of the times, we think of traditional imagery like satellite or aerial, pictures, pretty pictures and base maps. But in ArcGIS, imagery really encompasses more than that and includes thematic raster data and a lot of different data sets that help you model different variables and different types of information. So this data set here, we can go ahead and add to our map. And this is an imagery layer. It's been published as an imagery service, which offers some additional benefits over traditional vector types of data, right? So just looking at this data on the map here, I can click pretty much anywhere on the map. And this is basically comprised of a bunch of little pixels that contain information, in this case, about things like PV power potential, irradiation data, even optimum tilt of PV modules at that particular latitude. So this gives me a really good initial understanding of the overall potential for different factors that go into solar development. And since this is an image service, I've actually got access to the underlying pixel data, and I can update or change how this information is displaying here on my map. So associated with this layer, I've got all of these different kind of pre-built renderers that let me visualize something completely different. And applying these different renderers automatically updates how the information or layer is being displayed on the map. And this is all happening server side, right? So I don't need to have, the same layer loaded in multiple times, consuming, storage on the back end, multiple places. This is a really efficient way to look at raster data and be able to serve it up and visualize it in many different formats using these raster functions and some of the capabilities of these imagery services. So a lot of great content beyond just kind of solar assessment and resource data is also accessible in the Living Atlas as well. So if we think about some kind of common layers that we'd like to include in some type of suitability analysis for a new solar project, we might think of things like terrain, and more specifically, different types of terrain and how that can be visualized. So things like aspect, right? Here in the US, aspect, is very important because we're in the Northern Hemisphere. So any solar projects, are probably going to get their maximum efficiency if they're facing kind of in a southerly direction. So this layer here helps us illustrate where the landscape and how the topography of the landscape is configured, right, based on the direction that it's facing. And this helps us visualize that really anywhere we're interested in. Very similar to that, we can look at information like slope. And that's another, important factor in solar development. Obviously, the flatter the better, but if we get into areas that have too much topography, it can be very expensive to develop. There's additional construction costs and other things that need to come into account there. So looking at all of these different data sets helps us identify where these suitable areas are based on all these input criteria. And the final one we're looking at here is this Esri 2020 land cover layer. So all of these layers are coming from the Living Atlas, but this one in particular shows how land is currently being utilized. And if we look at our legend here, we can see what these different colors and shades mean. So for solar development, obviously we're going to be most interested in areas that aren't really developed, but are maybe still close to areas with high demand, looking at things like grassland, scrub and shrub areas, and maybe avoiding some of these more built up or developed areas. So a lot of these different layers, really play an important role in understanding where the best location is to site a solar farm. But most of you, are not going to sit here and toggle through different layers and look at them individually. It's just not a scalable workflow and not something that is going to allow us to really zero in and find the best locations. So how can we take all of this data, maybe that's coming from the Living Atlas or even some of the data that you guys have within your own organizations, and really operationalize all this information so that we can use it to find the best locations. Moving into this application, we see some capabilities that we have to actually do some of these models. So many of you are probably familiar with the idea of suitability modeling. And for the most part, that's a desktop workflow that you can certainly use to bring in a bunch of different data sets and set different rankings and weights and criteria and identify the most suitable locations for what you're looking at. But a lot of those same concepts also apply to the web here. So in ArcGIS Online, we've got a suitability modeler widget that you can load into Web App Builder, and you can actually configure this using a customized weighted raster overlay model that uses a bunch of raster and imagery data sets. And doing this allows users that aren't maybe traditional GIS users to actually run this analysis completely through the web using configurable tools without needing any desktop or GIS experience. So how this suitability modeler tool works is you basically have input layers that you can choose to include. And for solar, we're looking at things like elevation, land cover, slope, aspect. We may add additional things in here like proximity to transmission or resource potential. The list is really endless. But after you configure your layers, you can basically configure this model to set different rankings based on the criteria that you're interested in. So for elevation, for instance, we may rank these a little differently. For land cover, we're going to prioritize barren land, grassland over things like developed areas or wetlands. For aspect, obviously, we're going to prioritize southerly facing areas over northerly facing areas since we're here in the northern hemisphere. And once we configure all of our rankings, we can associate weights to each of those different input variables. And this tool is really nice because on the back end, it uses some of those raster and imagery capabilities that Alessandra talked about to do all of this analysis in the cloud. So when I click run, we'll basically generate on the fly a raster data set that shows me basically the suitability for the entire US for solar development based on these different input criteria that I've specified. And this can scale really easily, right? I don't have to sit here and work at my desktop or workstation and wait for this thing to finish processing. I basically click a button, it's all handled in the cloud, and then the output pops up here on my map. And this really allows me to visualize where those areas are that have the highest potential, which are indicated here in these kind of green, darker green colors, and everything in the yellow and orange and red colors would represent a lower suitability. So we could obviously feed this into another process to really narrow down specific areas that we're interested in, maybe based on property ownership and some other variables. So running through that process, we get back to where we started, where we've identified a specific area of interest based on all of those input criteria. And now we're ready to perform more of a remote assessment that's a little more detailed and localized for this particular area. And that's really where imagery, specifically satellite imagery, can come in and play a huge role. So traditionally, if we wanted to evaluate the site, we may send people out and do boots on the ground type of investigation, right, where they're reporting what they're seeing. But now a lot of this can be done remotely. So if we toggle on a satellite imagery view that was collected, in this case from Maxar, we can see an up-to-date view of what's on the ground there. And we have different resolutions that we can choose from. So the Esri imagery-based map may not always be the most up-to-date in the specific area that you're looking at, but bringing in this kind of premium satellite imagery allows you to get down to the specific level of detail and the granularity that you want. So using the satellite imagery, we can see, obviously, there's some construction and development of what appears to be a building over here. Once that resolves a little bit, we can see there's an existing road here within our AOI. We see maybe there's a fence line. We get a really good sense of what the existing landscape looks like. There's a creek over here. It looks like there might be a little bit of slope on this map or within this area. And we just get a really good assessment of what's going on. Of course, we can confirm that, bringing in those layers from the Living Atlas, like our terrain, aspect layers, our slope map, and any other content that you may be interested in. Or you can even go and collect things like LiDAR or do your own kind of virtual assessment using things like drones. And we'll get into that here in a little bit. But satellite imagery specifically offers a lot of benefits. So since the satellite imagery layer has been loaded in as an image service, I've got that same ability to come in here and change the display. And I can see using this renderer here that this is actually a 4-band image, which means it's got a multispectral infrared band associated with just the RGB bands. So what that allows me to do is actually perform analysis on this imagery to derive additional information that might not be overly inherent just looking at the natural color view of this. So a new capability to ArcGIS Online is ArcGIS Image for ArcGIS Online, which basically gives you the ability to do raster analysis completely hosted in the cloud. So if I select the raster analysis option, I've got this Analyze Image tool that I can easily run by selecting my satellite imagery. I can choose basically a type of analysis to perform. So we may be interested in doing a soil adjusted vegetation index. I can specify the NIR and red bands here, and then I can basically run this analysis. And in the interest of time, I've already got that output loaded into the map, and this is what that looks like. So what this is really allowing us to do is see through a different lens what the landscape looks like. And we can use this to identify areas that may have vegetation. If we need to clear vegetation for an opening to put solar panels or a substation, we can certainly use this to identify some of that information initially. Now, all of this is being done completely in the cloud, right? So there's no backend infrastructure to worry about. Obviously, a lot of these tools are comparable to things you can do in Pro and also with Image Server and Enterprise, but there's more options than ever now to be able to host and process this imagery, display it, share it, and then derive information from it. So with that, Alessandra, we'll toss it back to you.
Awesome. Thanks, Scott. I'm switching over my screen here. There we go. Okay, so now that we have our area of interest, we'll want to start moving into the planning and construction phase of our project. So obviously, we're really confident that you're all familiar with the idea of building this digital twin in ArcGIS and this virtual representation of real world processes, behaviors, relationships, and even project management out in the field. So we can even monitor the construction of our project using drone imagery or perform periodic spot checks to understand where we are in our scheduling, if we're ahead or behind of schedule. We can see very detailed information about where the materials are laid out in the project site, where critical equipment is located, or even personnel closest to a problematic area that needs attention. Or even once that the construction is complete, looking back to see how everything progressed over time to future replicate successful projects. And in the environmental due diligence process of construction, we can pull this imagery and data into environmental monitoring to ensure that our environmental impact is at a minimum. There are even tools in ArcGIS to generate flow direction models or compare elevation models over time during construction to visualize how our site would be impacted. Location intelligence plays a very critical role in the architecture, engineering, and construction phase of renewable energy projects. Those location-based workflows founded on the ArcGIS technology make these extremely complex projects easier to plan, design, build, and operate. So with that, I'll hand it back to Scott to show us this project management in action.
All right, thanks, Alessandra. So we'll pick up right where we left off, looking at our project with some up-to-date satellite imagery loaded in. Now, there's going to be a variety of workflows that may be of interest here for different people or different groups involved in the development process. We may have our engineering group looking for site layout information. We may have our environmental team wanting to get information about environmental impacts. And imagery and remote sensing data can really benefit all of the groups in this throughout this planning, design, and construction workflow. So one thing I'm going to load in here is our DEM of an area. So DEM stands for a digital elevation model, and this can be collected from a variety of different sensors. It can be collected from LiDAR. We can fly a drone and to get DEM. We can even derive it from other sources of information. But the DEM is really critical in allowing us to identify different things about the project site and how different groups may interact with the content in terms of developing out the project further. So one thing we can do with our DEM is feed it into all of these analysis tools that we have available through us or to us. And again, this can be done in desktop, it can be done in enterprise, but we're going to look at how this can be done here in ArcGIS Online. So again, if I go to my raster analysis tools available through ArcGIS Image, I've got this Analyze Terrain group that gives me a few different tools to choose from. So using this input digital elevation model, I may want to derive the aspect of the site. Maybe this DEM is a little higher resolution than the data we use from the Living Atlas, so it may be a little more accurate. But this allows me to actually perform this analysis on demand. So all I have to do is come in here and specify my DEM layer, and then select a result layer name where it's going to be stored, and I can go ahead and run this analysis. And this is going to occur completely in the cloud. And when that processing is done, it takes a couple of minutes, I'll basically have this new layer that gets added to my map. And again, this allows me to identify the aspect of this particular site, but at a much finer resolution than maybe the content available in the Living Atlas, since we're a lot more localized here. Now, this aspect layer, along with maybe a slope layer and any other derived products, could be shared with maybe our engineering group, who might bring it into something like AutoCAD to actually influence how they want to design the site layout for this particular location. But other groups, like let's say the environmental group, may also be interested in derived products that we can generate from this DEM as well. And if we look at, zoom out here, if we look at the base map, we've got actually a couple of different streams in the area. And we can see kind of the ravine here. Let me turn this off, turn it back on. And we can see kind of how water runoff from our site may impact the surrounding area, and especially in heavy rain events, right, might cause flooding. So what we really want to do is establish a baseline for what that water runoff looks like for our site before construction, and then we want to be able to monitor that as we move through construction and ultimately once construction is finished. So using that input DEM, we can run a series of analysis tools to actually generate water runoff characteristics. So loading in my raster analysis tools, I've got access to a library of what we call raster functions, over 150 of them, that allow you to manipulate and analyze raster data. And if I search for flow, I see a couple of different tools. One is this flow direction tool. I'm going to select that, and this is going to allow me to calculate the flow direction of all of the pixels that make up this digital elevation model raster data set. So all I have to do is come in here, select my DEM, set a few parameters, and then click Run Analysis. And what the output's going to look like is essentially another raster data set that will indicate the direction that water is going to flow from pixel to pixel over the surface of the ground within this area. Now, this flow direction doesn't really mean a whole lot, but we can use it to derive additional information like flow accumulation and runoff. So running that same analysis tool, but searching again for flow accumulation, I can use the input of that last process and again set some parameters to generate a flow accumulation surface. And what this is showing is basically the path or route that water is going to take over this specific surface. And we can see starting in the green, moving up to the yellow, orange, and red, that's going to be how it accumulates in this area. So obviously it's going to all flow down towards this little stream here, but this gives us a good sense of how water is going to feed off of this particular site. Now, again, we can use this for kind of a baseline for environmental analysis. We've shared our DEM derivative products to our engineering group. Now we're ready to kind of move into construction. And kind of switching gears a little bit, imagery offers really a range of benefits for construction. And this is primarily in the visualization space. So here we're looking at some drone data of a site, and this is directly adjacent to our solar site out there. But this allows us to do a lot of things in the construction monitoring phase of the project and really understand how our project is stacking up to the schedule and seeing where things are in relation to where they need to be. So over here on the left, I see a 2D view using our high resolution orthomosaic that we got from our drone. And we'll talk a little bit more about how that was created here in a minute. But we can use it to identify specific things on the site. One, we can see the progress of the construction. We can see where certain materials and resources are located on site. And we can even do things like identify heavy equipment and machinery. So I can see here we've got our crawler loader, a forklift, we've got a crane down here. And I can use imagery collected over time to actually see how those different pieces of equipment move, where they're being stored, located, and keep tabs on them. I can also load in additional information for planning purposes, like we see maybe our laydown yard up here. And this helps me really get a good picture of, one, the layout of the construction site, and two, the progress and change over time that's occurring. Over here on the right-hand side, we see a 3D view. This is actually an integrated mesh that was generated from the same drone flight that gives us a really good view into the realistic point of view of the site and get a good perspective of what it actually looks like. So as I pan around, we can obviously see all of the different components more in a 3D space. If I zoom over here to our laydown yard, we see all of our construction equipment, our construction material, and we may use this to identify, again, how material is being used, compare that to the schedule where we should be for this time of year, or at this point during the construction progress. And this can really just provide a enhanced perspective as to what's going on without physically needing to be on site. And I can see our solar panels back there in the background. So drones and imagery is can be very pervasive throughout the construction process, and we can fly these drones, as needed. It's very cost effective. It mitigates risk, and we can use those outputs here to drive decision making back in the office. Now, once construction is completed, we may choose to do the same series of analysis that we did before construction started and compare kind of what has changed over the course of that time. So using our post-construction satellite imagery, we see our solar panels have indeed now been built, and we can use the same workflow to generate those derivative information products to help us understand what has occurred. So looking at our pre-construction or post-construction, in this case a surface model, we can see the hill shade that was generated from that, and we can do the same thing that we did before, right? Generate a flow direction model and also a flow accumulation raster surface to identify how water runoff may have changed during the course of the project. Now, it might be a little hard to visualize in here, so I've gone ahead and added this to a configurable web app that allows us to actually do a swipe to see, in this case, how flow accumulation has changed. What we're looking at on top is the kind of pre-construction flow model, and we can see the channels that are detected here, and we can see that's actually changed a little bit post-construction. So this is obviously going to have slight impacts on the runoff of the water and flooding events and maybe surrounding environmental impacts, but doing this type of work helps us understand the overall impact that our project is going to have on the surrounding environment. Now, pairing that with all of our construction kind of monitoring tools, you really get a good sense of how you can use imagery to drive decision making and support and increase operational awareness during this planning, design, and construction phase. All right, with that, I will toss it back to Alessandra here.
Awesome. Okay. So now moving into operations and maintenance that we've had kind of more efficient construction workflows, imagery and remote sensing can have a really profound impact on our renewable energy projects as well. So we can use drone imagery to get a really detailed and up-to-date view of our assets. So SiteScan for ArcGIS is a new Esri product that provides complete end-to-end workflows by providing drone flight planning, fleet management, image processing, and analysis capabilities. With this complete end-to-end solution for drone imaging projects, drone operators can plan and execute drone flights, manage all of their flight data and metadata to support project requirements, manage their drone fleet to run safe and efficient drone operations, generate 2D and 3D mapping analytic products from drone imagery, and most importantly, publish these drone mapping products to ArcGIS Online, ArcGIS Enterprise, or even Autodesk BIM 360. So we can use this drone imagery to perform remote inspections of our assets and save time and resources of putting boots on the ground. And of course, all of this information can be shared back to ArcGIS, and that information can be consumed by the organization in the maps and applications that are most relevant to their workflows. So not all the imagery in operations and maintenance will come from remote sensors like drones. Of course, we will have staff on site performing inspections and maintenance on our assets that may capture imagery on their devices like phones or tablets. So this information historically has been isolated to those paper forms or on those devices. So Scott and I really wanted to showcase how to take this content and bring it into ArcGIS, using Esri's out-of-the-box field applications so that we can add so much more value to our workflows every day. This is where oriented imagery comes in, and ArcGIS allows you to leverage and manage this oriented imagery taken on site at problematic areas or maybe areas that need attention or just informational areas. This is incredibly powerful because those photos taken are more realistic when most of our work is done from that bird's eye view looking down. Of course, in building our renewable energy digital twin, we want to access, analyze, and display as much data as possible to provide actionable information for better business results. So for our last demonstration, I'm going to hand it back to Scott one last time to show what's my favorite part of the webinar, using SiteScan for ArcGIS and Quick Capture and field data verification during the operation and maintenance part of our renewable energy life cycles. Scott, over to you.
All right. And, I have to say this is probably my favorite part too. I think we saved the best for last because there's really a lot of cool stuff that you can do with the drones and oriented imagery that we'll take a look at here. So as Alessandra mentioned, right, drones are becoming increasingly popular, especially in the operations space, as it provides a way to quickly and efficiently remotely monitor operations and do asset inspections and all sorts of stuff. And really, we can see the value of drones many different ways, right? So if we're just looking at our project here using the imagery base map, we can only zoom in a certain amount before it comes all grainy and pixelated and really not usable at all. But loading in a nice high resolution orthomosaic from a drone flight, we can really derive information and see the actual condition of our assets and the condition of the surrounding areas out there within our project site. But how do we get all of this drone content into ArcGIS to even begin with? That's really where SiteScan comes in. So Alessandra mentioned SiteScan is one of our newer products, and it's really an end-to-end drone solution. Everything, supports everything from flight planning to data capture to processing and storage, and ultimately the analysis and sharing of that information out to the organization. So here within our SiteScan Manager, which is a web application, we can see all of the outputs of our drone flight. So we see that same high resolution orthomosaic right here, but it's also got built-in tools that allow us to take that information or take this data a little further and actually derive information from it. So what I've got over here are a series of different tools that allow me to do things like perform measurements and even do inspections. So if we zoom into one of the areas here, we see we've got an electrical component, maybe a combiner box or an inverter out here in the field, and maybe we want to do a remote inspection of that. Using our tools, we can actually click any spot on the map to perform an inspection. And what it does is it drops a point on the map there. Sorry about that. And what that does is pull up all of the raw imagery collected from the drone that allows you to see that particular point from different vantage points, different perspectives. So we can blow these images up, we can zoom into them. We've got a little spotlight feature that highlights that particular location there in the image, and I can actually pan through all of the images that have that same location somewhere in them and see that location from a bunch of different perspectives. And this is really helpful if I'm trying to do these remote inspections and I want to get a good sense of the thing that I'm looking at from a bunch of different angles. So one of these is a behind, there we go. We've got kind of a behind the the panel view here. And if I turn off the spotlight, we can actually do a number of different inspections, right? We can look at things like the mounting system, or we can identify maybe areas where there's soil erosion from water runoff coming from the top of these panels. So there's really a lot you can do with this inspect tool here within SiteScan. And it's one of the many kind of features that are available here within the web viewer. Now there's a lot we can obviously cover here within SiteScan. We could probably spend a whole webinar on it, but in the interest of time, I want to show you just one more thing, and that's the 3D point cloud that gets created. So there's a number of different processed information products that get created in SiteScan as a result of your drone flight. But this point cloud is really cool because it allows you to see more or less a digital twin of your site. And I can zoom in here and I can see all of the solar panels, the angles. I can rotate this from a bunch of different vantage points, and I can really get a good sense of what my site looks like. I can also use some of the built-in tools to do different types of analysis. So one of them might be an elevation profile, and I can manually create an elevation profile over part of my image here, and I get this little graph at the bottom that shows me, in the context of the elevation, what I'm looking at in terms of the point cloud. So I can actually see the angle of each solar panel here. I can actually count the number of rows. I can see how this site slightly slopes off from this kind of west to east direction. And I can export this as a CSV, as a LAS file. I can bring it into other aspects of ArcGIS, classify this data, and actually do a lot more with it. So the possibilities are really endless here. And there's a lot that you can get from data collected from these drones. Now, if we go to kind of switch gears a little bit, as Alessandro mentioned, not all of the imagery collected out on site is going to come from sensors like satellites or drones. A lot of you have field staff out there that are doing inspections or performing maintenance. Maybe they have tablets or other types of devices that they're collecting information on. We can take advantage of the imagery collected during those types of visits and put them into the same system and add them to the same type of visualization so that we can get context and derive additional value from that. So here's a quick little video of how you can use our configurable app, field data collection apps, to actually collect not only observation-based information, but associated images and feed them into the system. So I'll narrate over this while it plays. This is going to be using our quick capture application, which is all about rapid data collection, and it's really a big button app. So we have all of these buttons over here on the side that are basically preloaded to collect a specific type of observation. When you click on a button, it could be configured to capture an image. It can optionally be configured to collect a short description of what you're observing, and then that information gets collected as a point on the map. And in a few seconds, we'll see that point sync back to our layer coming from Portal or from ArcGIS Online, and that essentially allows us to bring it into all of these different maps and understand what's been collected out there in the field. So I can take the output of my quick capture app, or it could be field maps or Survey123, any one of our different data collection apps, and feed them into something like a dashboard where I can get a good overview of all of the observations that have been collected. And in this case, we see different types of observations. We could have damaged components, exposed wires, soil erosion, and I can click on any of these and I can get a pop-up here that shows me that picture as an attachment to that particular feature on the map. So looking at the data in this format is certainly helpful, but it doesn't tell the whole story. I don't really know how this image is oriented to the view that I'm seeing in the image versus the point on the map. So there can be a little confusion in terms of what direction was the camera facing, what are we actually looking at, but there's a solution for that. We have a product, or really a data model called the Oriented Imagery Catalog, that allows you to take all of this oriented imagery coming from devices, drones, really any sensor that's not nadir or direct down, and let you incorporate this into a map. So to open that, we've got our Oriented Imagery Viewer app, where we've loaded in the same exact data. So we see all of our points, and then we see all of these triangles. These represent basically the coverages for all of our images that we're taking. And using our Oriented Imagery widget here, I can click on any point here within these coverage areas, and I see the image pop up. Now there's a couple of things going on here. One, I see the image or the location that I clicked on and all of the images that cover that particular area. So I can see what different angles those images are coming from. And then two, I can also see the points that I clicked on the map kind of superimposed on top of my image. So I can see exactly where the location is on the context of the image. And as I zoom in and pan around, you can actually see that field of view, that coverage map update over here within the map view. So I can really have a good perspective of what I'm looking at. I can click around on different points, right? So let's say we go up here to this area and we've got maybe a different view. I can actually see pretty clearly, in this case, the mounting system. Maybe we've got some rust there that we need to address. If we go over here, I've got maybe a combining box or a motor system that we can inspect. So there's really a lot of useful ways that you can use this oriented imagery, and it can be shared with the larger organization. One of the challenges with this oriented imagery or data that people are collecting on their devices is that it doesn't go anywhere, right? It just stays on that device or it gets shared to a folder, but people don't know how to access it. This kind of standardizes all of that, puts it into a common data model and makes it accessible through some of these configurable apps. Now, taking this workflow just one step further, we can actually operationalize this a little bit. So if we're looking at an observation that was collected and something needs to occur, like a follow-up inspection at this location, how can we actually kick that process off? Well, we can use something like Survey123 and maybe a combination of workforce. So some of our different mobile apps on the back end to actually facilitate that process. So here I've got just a simple form that's been added into my map, and I can click the point here on my map within my form, and I can specify the location. Maybe this is panel 1, 2, 3. We want to create a follow-up inspection for maybe this is an inverter, right? Give it a description, please inspect, give it a priority, maybe a work order ID, and then a request date and time. So I can go ahead and submit that, and what that's going to do is basically create a new item, maybe a point on the map, a new assignment that gets shared out to a specific worker that allows them to understand where work needs to be done and what the nature of the work is. And then of course, all of this could be tracked through something like a dashboard if you wanted to understand the current status of observations versus outstanding activities, and you can track and monitor the progress of all of that over time. So there's really a lot of cool capabilities here in terms of what's available, but it's all really in the vein of supporting operations, making it more efficient and delivering enhanced value across the project development lifecycle. So with that, Alessandra, I'll toss it over to you for the last time.
Awesome, thanks, Scott. Like I said, my favorite part of the webinar, I think it's super cool and workflows that we haven't really seen before. So yeah, on this screen, kind of a summary of what we covered today in the webinar. As Scott said, we are here to make your workflows as successful as possible. So, we wanted to cover the entire renewable energy life cycle and how imagery is used throughout every process. So pulling in, ArcGIS content from the Living Atlas or utilizing other imagery sources, that really seamless integration into ArcGIS or even pushing that information out to other ArcGIS products, really kind of using that location intelligence for better design and construction workflows, utilizing site scan for ArcGIS for remote sensing or even ready to use Esri applications, and overall enabling those really efficient operations and maintenance workflows, the entire process. If you've been to any of our webinars before, this is something I always like to do, is show you the products that we use today. A lot of these, if you have, ArcGIS is already available to you, but if you're really curious about how to use these applications or implement any of these workflows we showed today in your organization, feel free to reach out. We're happy to show you how to better use these applications or help you get started with any of these if they're new to you. And with that, I'm going to go to questions. So before I do that, you'll notice there's someone on the screen who is not part of this webinar. Chris Shiel, he is new to our natural resources team, and he's a senior account executive that is exclusive to imagery and remote sensing. So, here's our contact information. We really encourage you to reach out to us. We support the renewable energy team, and Chris will be involved in a lot of those conversations because he is an absolute fantastic resource to our team. We're really excited to have him. So with that, we are going to go to questions. I think we have Jeff helping us with those.
Absolutely. Thanks, Alessandra. Thanks, Scott. Great demos. Got a lot of good questions coming in, and I think maybe Chris can jump in and help us with a couple as well. So I'll fire it off. First one, maybe Scott, you can jump in on this one. Do all these raster analysis work on the portal, or would they need image server extension as well?
Yeah, good question. So we saw a lot of raster analysis tools today that we were primarily executing through ArcGIS Online. So we have a new product called ArcGIS Image for ArcGIS Online, which is basically raster and imagery hosting and analysis completely in the cloud. So there's no infrastructure needed. You don't need enterprise. You don't need image server. If you have ArcGIS Online and you want to be able to do these types of workflows, all you need is that. And that's basically an image or a add-on extension that you associate to a user type. Now, of course, you could still leverage image server if you have an enterprise deployment, you've got image server. Everything we looked at today can be done through that. And then we can also do a lot of the similar types of workflows through Pro, right? So we see a lot of these capabilities are available in multiple different parts of the platform. It just depends kind of what you're wanting to use and what you have access to.
Cool. And kind of along those same lines, Scott, is it possible to use a Living Atlas to derive products for other users in ArcGIS Pro, like specifically downloading a DEM data from the Living Atlas clip to a certain extent for further analysis, or does this need to be processed in ArcGIS Image for ArcGIS Online?
Yeah, good question. The image services and content from the Living Atlas can be used across the platform, right? So we showed primarily ArcGIS Online as the client application that we were using, but you can browse to all of that content, you can pull it into Pro, and you can work with it just like we did in ArcGIS Online. It really comes down to the individual item that you're working with. A lot of the items that we looked at today, like the terrain layers, are all configured for analysis, so you can actually use them in analysis workflows. Like there might be some limitations around the area or extent that you can make a request from, since it's an image service, but a lot of these data layers you can also download if you need to do larger areas of processing, or if you need to scale it up with some type of local analysis. So if you're interested in doing analysis with these Living Atlas layers, I'd encourage you to go to the Living Atlas, pull up the item details page. It actually tells you what you can do with that layer, how you can access it, the types of supported visualizations, analysis workflows, all of that good stuff is really baked into the details of that layer.
Cool. The next one really kind of talks to the apps you were showing, and the question was specifically, is the Solar Web App Builder app available to be accessed or downloaded for use?
Yeah, it's a really good question. The specific app that we showed was just configured using out-of-the-box tools, right? So we took Web App Builder, we took a already generated or published weighted raster overlay service and just configured it with the Suitability Modeler tool. Now, if you wanted to use your own data, let's say you had your own raster data set or your own weighted raster overlay service with all of your different criteria layers, you may want to publish that to something like Image Server, right? And then you can configure that to be used with that widget in Web App Builder. There's not really a public version of that app, but you can easily recreate it since it's all out of the box, right? It's just a simple configuration, pulling together the different tools and capabilities.
Cool. How about the Suitability Modeler? Does that have to be published as a GP service from ArcGIS Pro?
It can be, but it doesn't have to be. You can certainly publish a geoprocessing service. If you've got something like a model builder model and you wanted to be able to run that through a web interface, you can publish a GP service and support that either using ArcGIS server or image server if you've got raster data. But the specific suitability modeler widget that we looked at uses a special type of layer called a weighted raster overlay service. So that's actually something that you configure in Pro, you publish it up as a web service, and then you can configure it with that widget. And there's all types of documentation and steps online for how to do that. So if you've got a specific question about that workflow, feel free to reach out and we can kind of walk you through it.
And then another good question, Scott, what was the resolution of the elevation data you were using for the slope and aspect calculation?
Yeah, I was just looking at that. Again, in the item details page of that item in the Living Atlas, it'll tell you all that information. I think the terrain data set was a 1/4 meter, so 0.25 meter cell size, which is actually pretty high resolution since it's a global data set. But again, if that's not high enough resolution, you can certainly create that derivative product from a digital elevation model that you might get from LiDAR or from a drone. Those are going to be a lot higher resolution. You know, it could be down to an inch resolution. So you'll be able to get a much more accurate model. It just depends on the source data set you're using. But yeah, for that particular data set coming from the Living Atlas, I think it's a 1/4 meter.
Cool. And then another question from Ben, he says, major challenge for siting projects is identifying power infrastructure, transmission and distribution lines, as well as understanding competitive planning or existing power plants. Do we have any resources to help address those challenges?
We do. We have a few data sets in the Living Atlas. I didn't touch on them today, but specifically we've got a transmission line layer that is sourced from basically the national government and the data that they're collecting. That's a vector layer, right? So it's just a line layer that's a web service through the Living Atlas. You could certainly use that as an input to a raster analysis tool to generate, let's say, a proximity to transmission layer that looks at the varying distances from that line location as you move out. Now, for some of the other data sets like existing or proposed projects or substations, a lot of that information we rely on partners. So we have a very good partner in this space, Energy Acuity, which was acquired by Enverus. They have a ton of data that can be useful for renewable project development. They're actually listed online as an Esri partner. They have a offering in the marketplace, so feel free to go in there and do a quick search. You'll see information about the products and services and data that they offer, and that might be a really good source. There's obviously others out there, but that's the one that comes to mind.
Perfect. And I think we've got time for one more question. If an operator had different places and facilities in different countries, what kind of resolution might they expect to see as they moved around that sort of Living Atlas around the globe? How would they look at different resolutions of different data sources that you were showing there in the US?
Yeah, good question. I think it really comes down to the area that you're interested in. Some of these layers, like the global solar atlas, the terrain, the aspect, the land cover, all of those are actually global layers. So for the resolution that they have, 1/4 meter in the terrain case, I think 10 meter resolution on the land use cover data, a lot of that can be used wherever you are located around the globe. Now, there's going to be maybe some other things that you want to incorporate into your analysis that may not have as good of resolution, or there may just be data sets that aren't available in certain areas. It really just comes down to the content providers in those different countries, right? The federal governments and local governments, and also third-party organizations and where they have data available. But obviously the US, right, is the area that we focused on. That's where we have a lot of content. So that's one reason we focus there, but it's going to change depending on where you're looking at around the world.
Cool. Thanks everybody submitting your questions. We had some great questions today. We really appreciate the feedback. We are going to supply the recording to everybody that was on the webinar today. So if you want to share it with your teams afterwards, that'll be available. And thank you, Alessandra. Thank you for Scott for all the time putting into this. I think it was a really good webinar. And thanks for everybody for attending today.
Yeah, thanks everyone. Have a good day.